Hello and welcome back to the Data Unite channel. Today we are going to understand how to implement the logistic regression machine learning model on a real-world dataset where we are interested to predict whether a person will open a bank account if the bank targets that person during its marketing campaign. So in order to implement this problem, first I need to implement and to import all the necessary frameworks that are going to be used by us and Python. And we need to import first, in the beginning I imported warnings, which just helps me to not show all the warnings when I'm deploying the functions. For example, if a function is deprecated or something like that. And then I have to import pandas and matplotlib because I'm gonna also make some charts, and pandas because I'm gonna work with data frames. I'm gonna import pre-processing from sklearn because I'm gonna do some pre-processing on the dataset before using it into the model. I'm gonna use also stats models because inside with this framework, we're going to select which features are going to be useful for our model. Then also train and test split, which is used only for splitting the dataset into training and testing split datasets. Then importing the logistic regression machine learning, and also I'm gonna import a classification report framework, which is used in order to show the performance of the model. So first we need to import the dataset. So we do it like this: pd.read csv. The name of the file that I'm gonna use is called banking CSV, and it has a separator, semicolon. And now if we want to see the content of the dataset, we're gonna do like this. So we're gonna call the head function on the dataset, and we see that we have 21 columns, and I'm showing only the first 5 rows. But if we want to see how many rows do we have like 41,000 rows. And this value also can be seen with the command shape, and it shows the first column. The first number is the number of rows, and the second number is the number of columns. So I'm gonna leave that in this moment. And since our model takes only numerical values, and we see that we have features or columns where the values are textual, so string, we need to find a way how to transform these values here into numerical. And for that we're gonna use some sort of pre-processing for the data. And first let's see if we have some null values, and then we will continue with the rest of the pre-processing data, and then with the implementation of the dataset into our model. So let's test if we have some missing values. Okay, we can see that none of the columns have missing values. Also, I forgot to point out that our dependent variable, or our result, is the y column, which takes 0 or 1, meaning that if it is 0, the customer or the person will not subscribe to the bank, so they will not open an account. And if we have 1, that means that the person will open an account with the bank. The next check is also we can see if we have some duplicate rows. So we do it like with the following function, which is called duplicated. Any. So this says that there are some duplicates. So let's show here below the shape of the dataset before and after dropping the duplicates. So in order to drop the duplicates, we have to call the following function. So we always call the dataset first, and then we write drop underscore duplicates, open and close parentheses. Okay. Duplicates. Okay, I added an R. Okay, it was a typo. Okay, so we can see that after dropping of the duplicates, we have 41,176 rows, and before we had 41,188. So we lost 12 rows, which were duplicates. So now we can continue with our pre-processing of the dataset, because we are cleaning it, because if we have duplicates, then those duplicates will impact on the outcome of the result, because we are introducing noise to the model, and the model will not be able to process this sort of information, because we have rows that are similar or the same, and this shows a correlation, and that's why it will impact on the performance. So it's very important that before implementing any sort of model, we need to remove all the duplicate rows. The next step is to encode our categorical values, basically our string values. And for this, we first need to see which of the columns, so from this list here, which of the columns are categorical and which of the columns are numerical. So for that, we need to see the information of the dataset. And in the first column, we have the name of the column, then we have the number of null values, and then we have the data type of the column. And we can see that we have some columns like age, duration, campaign, and so on, are all numerical. Maybe it's gonna be integer or float, but it's a numerical value, which is fine for our algorithm. But these objects, so basically all the columns that are object, are not gonna work for our model. So we need to perform some sort of encoding, and we have different types of encoding. For example, one-hot encoding or target encoding. And one-hot encoding will increase our dataset by many columns, because for each value that we have in the column, one-hot encoding will create a new column. So if we have, let's say, 1,000 different values into the column job, then we will have 1,000 new columns created just from this column. And then we can also expect that from the rest of the columns that are with object data type. And in order to keep our data sets smaller, it would be better to use either target encoding or label encoding. And in this case, I'm gonna use label encoding, so that I'm gonna keep the data set into the same dimensions. So we will still have 21 columns, but the values will have some specific, the values inside these columns will have some specific numerical value mapped to their value. So in order to do that, First we need to split the dataset into two different datasets, one for numerical and one for categorical. This is a simpler way of how to implement the encoding, but you can also implement it directly on the dataset. But this is how I prefer because it keeps my work cleaner. So first, let's select all the numerical columns. And I'm gonna repeat the same for the categorical, where I will include the object. Okay, dataset. Okay, now I have the numerical and the categorical features into two separated data frames. So let's see the numerical. Okay, so we have also y, which is our dependent variable here. And if we see the categorical, we have all that are textual values. And now we need to call our pre-processing method, which is called label encoder. So we're gonna save it into a variable called le, and we are writing pre-world string label encoder. Okay, let's call it, and then I'm gonna apply this this encoder to our categorical data frame. So we do it in the following way. I'm gonna first label or create the name for the new data frame that is gonna be created after this action. So it's gonna be label encoded categorical. We use the apply function, and then we call the label encoder, and we call the fit_transform function. Now if we print the encoded values, we will see that instead of having words string, we will have numbers. So for example, for blue collar job we have the value 1, for technician we have 9, then for the marital status we have married 1, single 2, and so on and so on. Now that we have encoded our string values, we should again combine the two data sets, so the numerical and the encoded categorical features, into one data frame, so that we can use it to be implemented into our model. And to concatenate, or basically to collect all of them, we will use the concatenation function. So we're gonna do the following procedure. I'm gonna create the data frame, which is gonna be called df, and then I'm gonna call the pandas function concatenate. So pd.concat, and then I'm gonna insert the numerical data frame and the label encoded data frame. And here I also have to specify on which axis I want to concatenate them, because if I do not specify this value, then my dataset will explode. Basically, I will have it concatenated in both ways. It's gonna be it's gonna have double the columns, so instead of 21 I will have 42 columns, and also there will be double the rows, so it will be about 82,000 rows. This way, if I specify how I want to concatenate them, so I want to connect them together only column wise, so I want to append these columns to these columns here. And in order to do that, I'm gonna have to select the axis 1, which is the x-axis. And now we can see again the data frame. So now we have all the features numerical. And now our dataset is ready to be used in our model. And now we can skip also this step, but I want to show it to you how we can use also some sort of feature selection method. We're gonna see which of the features that are existing into our dataset are useful and which are not useful. So the first thing that we want to do is set the x and the y variables. So basically, in x we will have the data frame of all independent variables, and y is gonna be our dependent variable y. So basically what we want to know, that's gonna be into y. So to do that, we're gonna do the following step. We go the name of the data frame, we're gonna drop the y variable, so basically the y column, from the df data frame, and we are gonna save this result into x, and y is gonna be equals to the name of the data frame point the name of the column. This way, if we print, we have x, let's see, x info, we have all the columns except the y column, and if we do for y is not a data frame at this moment, we see that we have only the values for y. So we are done here, and now we can apply the logit model in order to determine which of the features into x are gonna be useful for our model, and we are gonna look for the p-value to be less than 0.05. So in order to implement this model, we're gonna do the following steps. Logit model sm, which is the statsmodel.api library. That one contains the logit function. We are gonna pass the dependent variable and the independent variables. And then I'm gonna call this model, so logit model, and I'm gonna fit it to these values here. So basically I have already defined where I want to use my model, and now I'm just gonna call it. And last, I want to print the result. So I want to see which of the features that we have into the data frame have the p-value less than 0.05. So we're gonna do print result, and print the summary. So here we see that we have the coefficients, the standard deviation error, z value, p-value, and the percentiles. We are interested into this column here for each of the features. And we can see that we have this feature here, this feature here, this one, and this one, which have p-values bigger than 0.05. And this means that these features are not going to be useful for our model, and we should remove them from our dataset. And I'm gonna do that. So I'm gonna save into the same data frame, which is x. I'm gonna do x.drop, and then I'm gonna write the name of the feature. So it was previous, then it's job. It's quite strange that job has a p-value this big, because you might think that if a person has job, they will be interested also to open a bank account, but also it means that they already have a bank account. So in this situation, it might be also useful to remove it. Housing. And the last one is loan. So previous, job, housing, and loan. And I'm gonna drop this features from the axis 1. Okay, so now if I print the info, I can see that I have dropped these features, and also I have that all the columns are numerical. At this stage, we have our dataset ready for implementation, and we can start with the preparation for the dataset to be implemented into our model, and also with the creation of the model. So the first step is that we need to split our data frames x and y into training and testing datasets. So in order to do that, we're gonna use the train test split feature framework. So we have x test, y train, and y test. As an input is x and y, and the test size is gonna be 0.3. And the random value is gonna be, or the random state, is gonna be, let's say, 100. Okay, and now we can start with building our logistic regression model. So first, let's define the model. Equals logistic regression. Okay, then we are gonna fit our model to our training datasets. So we have x train and y train. So model dot fit x train, y train. Okay, this means that we have our model fit to our datasets. And now we want to see, or we want to know the accuracy of our model. So we want to see if our model performs well when it's trained on these datasets. So in order to do that, we're gonna do the following thing. So print. I'm just gonna write a print statement just to have it as a complete sentence. So with model.score, we are validating the accuracy of the model, where we will put as inputs the X test value, so basically all the information from the X test, and the Y test values, because we want to check if our model is accurate when predicting the values for the testing data sets. So as input, we will put the independent features, which are the X test, and our model will perform a prediction on this data set. We'll create a prediction, and that prediction will be compared with the values in Y test. That way, we will see the accuracy of. Why do I get this? Okay, and we got dots. Okay, so we can see that our model has a 91% accuracy, which is fine. It's not the best, but it's fine, because we didn't do any hyperparameter tuning or some different types of modifications in the model. We just implemented by its default values, and we trained it, and then we are just testing it. So it's fine. We can do it better, but for this exercise it's gonna be fine also like this. Now we can also see the rest of the metrics that are very important in order to evaluate if a model is working fine or not. So we are gonna call the classification report, which will show us the F1 score, the recall, the precision of the model. So we're gonna do the following thing: print and for this we need also a prediction. So we're gonna do the following operation first. So we do model.predict, and I'm gonna insert the X test dataset as we said before. So this is the same operation that was done by this part here. So our model now will take as values this information here, will make a prediction and save it into this data frame, this variable, and then we're gonna use this variable here in order to verify the to compare the tests with the original values that were present into the Y test. So okay, so we have our report where we have the comparison between the predictions that we did with our model and the original values that were provided in our dataset in the beginning. And we can see that our model has a 92% of correct predictions for the category that the customer or the person will not open a bank account, and has a 66% of precision or correct prediction if the person will predict will open a bank account. So this means that for one class our model has good performance, but for the other class the model does not have a very good good performance. And we can see also that into the recall, because these two are correlated, precision and recall. If we have one that is low, also the other one is low. But if we see the weighted averages, we can say that our model has good performance, not the best. So this means that in any case we need to do some modifications into the model and try again, maybe change some hyperparameters or something like that. or maybe change the split of the data set, or maybe we need also a bigger data set. Or maybe in the end, that's the maximum that our model can perform, and maybe we need to look for another model that is more performant and has mathematics that is more complicated and has better power to do these classification problems. So this was all about implementing the logistic regression model on a real-world dataset. And as you can see, it's not that complicated, and most of the time that is spent is while pre-processing or preparing the dataset to be used for the model. But then when you see that you have a low performance of the model, then you need also to think about the changes into the hyperparameters. And we will see this part also in the future videos, because sometimes you have to do hyperparameter changes, because this will help a lot with the predictions in both situations, in classification and also in regression problems. Okay, so thank you very much for watching this video until the end, and see you in the next one. Bye bye.